Today we are going to talk about what is sequences and series, what is the differences between them, and what is the sequence of partial sum. So the main difference between a sequence and a series is a sequence is a list or a one-dimensional array, whereas a series is a sum of the list up to a specific term or infinity. So in calculus, a sequence is an enumerated collection of objects in which repetitions are allowed. There are elements in sequence which can also be called terms. So a sequence can be denoted as an within the curly brackets with limits that can be n equals to 1 up to infinity. So we can write it as a1, comma, a2, 3, a5, dot dot dot, a infinity. So if we write a sequence like this, an, suppose n equals to 1, 2, 5, so we can just write a1, a2, a3, 4, a5. We can cover this with brackets. So here we can separate each of the terms with a comma, whereas in the sum we are going to separate each of the terms with a plus sign. So what is a series? A series is a sum. It is not just a sequence of the terms, but a sum of the terms after a specific term or infinity. Let's see how we can denote series. Series can be denoted as the summation sign a to the power n, where n is equals to 1 to infinity. So it's basically gonna be, so it can be written as a1 plus a2 plus a3 plus a4 plus a infinity. So the main difference to take a look at here is, in sequence we write it like this. So an within second brackets and n equals to 1 to n equals to infinity, or the number the sequence is running up to. And the second difference is that we are separating them with commas. Here are all commas, whereas in summation we are separating them with plus signs. And this is a series. In a series we separate the terms with a plus sign, and we denote it like this: summation of an from n equals to 1 to infinity. Now let's talk about the sequence of partial sums. So to know that, we have to first know what is a partial sum. So a partial sum is a sum of part of a sequence. So we can write a series like summation of n equals to 1 to infinity a1 plus a2 plus a3 plus a4 dot 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 plus a infinity. So we can write it as a sum. So if we take the sum of one number, we can write it as s1. If we take a sum of two numbers, a1 and a2, we can write s2. If we take a sum of three numbers, a1, a2, a3, we can write s3, and so forth. So now this can be a sequence. So hence the term sequence of partial sums. So when we write the sequence of partial sums, so we know the sequence is denoted by this. So the sequence of sum can be recorded as s1, comma, s2, comma, s3, comma, s4, and so on. where we know that S1 is equal to the first term, S2 is gonna be equal to the A plus A1 plus A2, S3 is A1 plus A2 plus A3, S4 is gonna be A1 plus A2 plus A3 plus A4. So if you write the formula for these terms, we can write S1 is going to be A1 basically, because if you write the formula we get n equals to 1 to 1, because we are just taking the sum of first term, so n from 1 to 1 means only 1, and we can write S2 as summation of n equals to 1 to 2 an, S3 as summation of n equals to 1 to 3 an. So basically the sequence is going to be a sequence of all these sums. So we can also write as A1 comma to 3 and comma to 4 and so on. So this is a sequence of these sums, hence we come out with the term sequence of partial sums. So now let us find a generic formula for the partial sum. So let us find the kth partial sum. So we can write it as Sk equals to summation of n equals to 1 to k. So we're going to find the summation of first k terms, that is equal to a1 plus a2 plus a3 plus ak, and it is always going to be n because we are denoting the number of terms with n. So suppose if we used b or c here to denote the number of terms, here we would also have to write b or c. So from this formula we can see that if we are finding the sum of first two terms, we can write S2 equals to summation of n equals to 1 to 2. So this number is going to be here, same as this number. So if we find the summation of 4 terms, we are going to write summation n equals to 1 to 4, and mind it is a sub n. So there are a couple of series like geometric series, harmonic series, alternating series, telescopic series, and so on. So we're going to talk about those later. So today we talked about sequence of partial sums that can be denoted using this formula here.